Welcome fam to another video. This one's about different forms of energy. Get a load of this opening graphic. Whoa. So energy exists in a number of different forms, and energy can be transferred from one object to another or transformed into different forms of energy, which I touched on in the previous video about work. In stage 2 physics, no, it's not stage 2, in stage 1 physics, the expectation is that you'll be able to describe different forms of energy, including kinetic, elastic, gravitational, potential, rotational, kinetic, thermal, and electrical. You'll also be able to describe examples of energy being transferred from one object to another. You'll also be able to describe examples of energy being transformed, explain also qualitatively the meaning and some applications of various forms of energy, including kinetic energy and potential energy, and solve problems using these two equations. So kinetic energy equals half mv squared, and EP, which is potential energy, equals mgh, which is mass times the acceleration due to gravity times height. And lastly, you'll be able to describe energy transfers between objects and within different mechanical systems. So it does seem like a lot, but a lot of these learning objectives are description and explanation based. So once you've got your solid conceptual understanding, hopefully you'll be able to recognise what questions are asking for, and then just whip out your conceptual answer and just tailor it to the question in particular. So we'll do some examples and discuss what that means. I've already touched on some just in this little introduction, but take a moment to pause and think of different forms of energy off the top of your head. So pause this video for 30 seconds, I'm sure you will, and think about different forms of energy. Right, so I'm sure you've definitely paused it. Some forms of energy that I came up with off the top of my head were light energy, energy in food, energy in drinks, and some solar panel energy. So all of these different forms of energy fall into one of these categories. So for example, light energy, in a light bulb, that would be electrical energy and maybe a bit of thermal energy if the light is heating up. Solar energy is captured to form electrical energy, so it's the electromagnetic energy from the sun that is then stored and converted into electrical energy to power our world. Energy in food and drink is stored in the molecular bonds, and if you're doing bio, if you haven't already, you'll touch on how this energy is accessed by the body. So this is a table of the different forms of energy that we'll look at in physics. So first one is kinetic energy, and this is the energy of an object in motion. There are a few different types. First is translational, and this is due to motion in a straight line. There's also vibrational, and as you might guess, it's due to vibrational motion around a fixed position, so travelling back and forth over the same fixed position. Rotational energy, also as you may imagine, is due to rotational motion around an axis, so thinking about circular motion. There's also elastic potential, and this is energy that's stored when an object is stretched or compressed. So if you think about a rubber band that's been stretched, if you let go, it'll snap back into its original formation, so that energy is stored in the rubber band when it's stretched. Gravitational potential is the energy of an object due to its position in a gravitational field. And then there's nuclear energy, which is stored in atoms' nuclei, and it's released during nuclear reactions, so fission and fusion, etc. Electromagnetic or light energy, touched on this just before. This is the energy that's stored in electromagnetic radiation such as microwaves, visible light, X-rays, gamma rays, etc. Anything along the electromagnetic spectrum. There's also electric potential, and this is the energy of a charge due to its position in an electric field. A grammar apology for that apostrophe in the it's that shouldn't be there. There's thermal energy, and that's the sum of potential and kinetic energy of a microscopic object or system. And there's also mechanical energy, and this is the sum of potential and kinetic energy of a macroscopic object. So microscopic is a small, tiny object, and macroscopic is macro, so big object. Thermal energy and mechanical energy are the sums of kinetic and potential energy. So they're made up of constituent types of energy. The rest are made up of themselves. So, energy transfer. This is energy that's transferred between objects whenever work is done on or by an object. So, if an object does work, then its own energy content decreases. Whereas if work is done on an object, its energy content increases. So the energy of the object doing work is transferred to the object that is having work done on it. So for example, hammer and a nail, energy is transferred from the hammer to the nail when a force is applied. The hammer does work on the nail, so the hammer's own kinetic energy decreases, and work is done on the nail by the hammer, and this increases the nail's translational kinetic energy. So it's energy moving in a horizontal or a straight line, and so its horizontal position in the block of wood changes, so it gets nailed further in. With a basketball shot, energy is transferred from the human to the ball when a force is applied. Human does work on the ball, decreasing their own kinetic energy. Work is done on the ball, increasing its potential energy, and this is its gravitational potential energy because it's increasing its vertical position in the gravitational field on Earth. You'll become more familiar with the types of energy that you'll need to describe in these situations. It just takes a bit of practice and getting used to and just remembering the different types of energy. So, transformation. Energy is transformed whenever one form of energy changes into another. So an example of this is photosynthesis. For you bio peeps again, electromagnetic energy from the sun is transformed into electrical potential energy, which is stored in chemical bonds between sugar and oxygen molecules. This here is just an example. In physics, you're not going to be tested on your bio knowledge. So if you have a question asking to describe the transformation of energy, you'll have enough of an understanding of what's going on to be able to describe it. You're not expected to know content from other subjects. Another example of energy transformation is one that I stumbled across when I first moved to Dublin, which was almost 6 years ago. I was kicking around the city looking for some interesting but free stuff to do, and I ended up in a science exhibition and came across this display that was an iPod, so this iPod Classic. I'm not sure if you guys are familiar with this, but these are the OG iPods before iPhone. Anyway, this iPod was plugged into a lamp, and the energy from the iPod was powering the lamp. Then the lamp was shining, actually maybe I'll use this colour. The lamp was shining onto a solar receiver, and then a solar receiver was plugged into a speaker. So there was no wire connection between the iPod and the speaker. But the speaker was playing whatever the iPod was playing, and you could verify it by switching songs on the iPod to then play whatever you wanted to listen to. So if you weren't interested in listening to Feel Good Inc. by Gorillaz, you could pop on something different. It's a pretty good song though, so you probably would be interested in listening to that. Anyway, so what was happening here is that the electrical potential energy of electrons in the iPod was then transformed or converted into electromagnetic energy stored in electromagnetic light waves or photons. So the energy has been converted into this. That energy is then received by the solar receptor and then transformed back into electrical potential energy of electrons in this wire, and then that is then transformed into vibrational kinetic energy of the speaker cone and the air molecules around the speaker. So maybe you've seen on one of these speakers or any speakers that aren't covered, you might see the plates of the speaker vibrating. It's particularly noticeable if there's a lot of bass in your tracks. So there's two types of energy that you'll be able to solve problems about, and they're kinetic energy and potential energy, gravitational potential energy. The kinetic energy, as we touched on before, is the energy of an object in motion. So this can be translational, vibrational, or rotational. You'll only have to solve problems about translational kinetic energy. The equation for this is half mv squared, and obviously because we're talking about energy, the units are joules. Mass is in kilograms and velocity is in meters per second. So an example, what is the kinetic energy of an 11 milligram fly moving with a velocity of 18 meters per second? So to do this, we've got our rule, kinetic energy equals half mv squared. Our velocity is 18 meters per second, and our mass is 11 milligrams. We need to have everything in, or mass in kilos, so 11 milligrams is equal to 11 by 10 to the negative 6 kilograms. So a milligram is 10 to the negative 3 grams, but because we're talking about kilograms, milligrams will be 10 to the negative 10 to the negative 6 kilos. So milligrams, to get from grams to milligrams, you times by 10 to the negative 3. Because we're going from kilograms to milligrams, you times by 10 to the negative 6. Anyway, back to our equation, sub all of that in, so kinetic energy equals half 11 by 10 to the negative 6, and then by 18 meters per second squared. If you throw all of that into your calculator, you should get something along the lines of 0.00178 joules, and that is equal to 1.78 by 10 to the negative 3 joules if you're writing that in scientific notation. So the other type of energy that we'll have to solve problems for is gravitational potential energy. So this is the energy of an object due to its position in a gravitational field, The rule is potential energy equals the mass, which is kilos, times by g, which is the acceleration due to gravity, and that's meters per second squared, and height, which is meters. And then the overall unit for energy is obviously joule. For an example, what is the potential energy of a 15 kilo box that's raised 3 meters above the ground of Earth? So for this, we'll just use our rule. Potential energy equals mass by g by height. Throw all of our values in. So we've got a 15 kilo box. We don't have to worry about doing any conversions because the unit that we use is kilos. And then gravity, which is 9.8, and then height, which is 3 meters. I haven't been too particular with sig figs here, but this would be 3 sig figs. This would be 3 sig figs. If you only use 9.8 for gravity, then your total sig figs in your answer would be 2 because this is only 2 sig figs. However, if you did 9.81, then you'd be able to use 3 sig figs in your answer. Anyway, throw all of this into a calculator and you should get an answer that looks like 441 joules. So that's how you do these type of questions. You might get some questions that will give you the energy, the potential energy or the kinetic energy, and you'll have to find the velocity or the height that the object is at, and you can just rearrange these equations to find those values. In class, we'll have a go at deriving these equations, but that is it for this video.